Hello, fellow Haskellers, and welcome to Giggles is You, the show where I re-implement one of my favorite puzzle games, Baba Is You, in Haskell, while I answer all of your questions about Giggles is You, Baba Is You, or Haskell. So let's get started. So today I want to implement the push feature. So in Baba Is You, you can control the rules of the game. We're not yet at that stage, but we can use a debug menu in order to enable and disable various rules. So I want to add a new kind of rule that we can toggle on and on. And that rule is that an object is push. Like in a Sokoban-like game, if you have a box, you can push the box, but only like if there's not two of them next to each other. That's not the case in Baba Is You. If there's a sequence of objects that are all push, you can push the first one and push all of them, I think. At least that's how I plan to implement it. And one question I had about it last time was, what if an object is push but not stop? And I wasn't quite sure if there's an object that is push, like a box that is like smack against the side of the level or against a wall that is stop but not push. What if I'm here and I try to move to the right? If I can't push this object, should I walk over the object? And it turns out the question was like slightly ill-defined because in the real game, if you form the rule that an object is push, implicitly it also makes the object stop. So normally you try to walk onto it and you can't. But like I think later on in the game, like you can form both that an object is push and an object is not stop, in which case the thing that I would expect, that you try to walk, you can't push it, but you can walk out of it, does happen. Presumably they put that like later in the game because that's a less intuitive behavior. But for my re-implementation, I think I want to keep the rules very separate. So I think I will have object is push and object. Hello, Masa. Say hi. Hello. Separately, object is push and object is stop. Let's do that. But first, I would like to show you some quality of life improvements. So I've been a bit unhappy about the time it takes to recompile the game every time I want to run it. Like stack, run, and then we wait a little bit, and then we wait a little bit more as it recompiles all of the files. Looks like 5 of those files don't need to be recompiled. That's great, but it still takes a lot longer than I would like. And so I found a way to make it run much faster. And like this has to do with, okay, let's just wait until it runs. Any moment now. Now you see why I want to do this quality of life improvement, right? It has to do with threads. So, okay, so finally we have the game. And I can move around, and I can write some command, like this character at the top left is called sheets. If I call name is you sheets, then now did not work. I know why. In fact, the fact that the command did not disappear when I press enter, it was supposed to be a clue that this did not parse as a valid command, like as if I had forgotten to close the double quote or something. But the reason is that that was the old syntax. It used to be that all of my objects had string names, but in the last stream I improved things to use an algebraic data type. And so the name of sheets is now sheets name. So now I press enter and the command has appeared. It means it did work. So if I move around, now sheet moves as well. Okay, so one of the changes is that you used not to be able to see this text because the window was like all the way up. So for the typing name is you, like you can barely see it. So I changed like the default position so that it appears a bit lower. So I did that here. I can control the position at which the window appears when I use gloss, and I just don't know why I had -10 before, but now I have 50, 100, which is about here. Okay, so that's one of the changes. The other change I will, now I can tell you now, it's just that I had noticed some redundancy. Some code was being duplicated. I just refactored it to 2 helper functions. One to, let's see how long it takes if I haven't changed anything, so that I can show you what are the things. It's not that long when I haven't changed anything. So draw generic text is if I have a string like the word giggle, sheets, the word text, or just the letter A, I just draw it to fit a box. And the other draw generic object is very similar. If I have the name of an object, no, not the name of an object, still a string, such as the letter A or the letter B, I draw it inside of a green circle, because that's how I distinguish the objects from the names of the objects, except for Giggles and Sheets, which have dedicated icons, for which I must thank my coworkers for having drawn them before I moved this presentation from a work-only presentation to a Twitch stream. All right, so that's still not the quality of life improvement that I wanted to show you. Where is it? There it is. It's a file called Quick Run. It looks like this, and when I run it, well, now we won't see a difference, will we? Because I haven't changed any files. Actually, it seems slower than just Stack Run. I think it is because Stack Run is using the compiled version, whereas Quick Run is using the interpreted version. So it still needs to recompile a bunch of stuff, but I've found that if I change a file and then call Quick Run, it's much faster than if I change a file and then call Stack Run. So I want to explain what is the magic. Oh, and since it's interpreted, like, it's a bit slower, but like it's a very simple game. I don't think performance matters much. So let me show you how this works. So Quick Run is calling GFCI with those mysterious options, and then I run main, which is just the main function which starts the application. So what is this FNO GFCI Sandbox? It's something I have learned from the Gloss homepage. So on the package page for Gloss, there is a link to their homepage where they display a bunch of examples of what you can do with Gloss, and then there's an FAQ, and somewhere in there, it should be here. There's the very first one. Let me increase the font size. The very first question is that Gloss freezes in GFCI, and indeed, if I do stack GFCI, oh, I must specify the target. The Giggles is ulib, otherwise it will try to run. It will try to load everything, including my custom version of Gloss, and I don't want that. I don't think I have a custom of Gloss anymore. I'm not quite sure. Okay, so I can now, like I'm in the REPL, I can run a variety of functions. 2 + 2 is 4. Just rough type int is 4. 2 + 2 without a type signature is a warning, and 4 apparently. But I can also run any functions from the game. I've done that in previous episodes in order to debug. So for example, parse level of dot ABC. Doesn't have a show instance, but I can put it in a variable, ask for its type, and use my print level function to get it back. So I can use all of the functions from my implementation, including like test all, for example. I'm going to run all of the tests, which just prints nothing upon success. It only does something special upon failure. And in theory, I should also be able to call main. But this is what happens instead of displaying the window of the game. Glut, fatal error, internal error, inconsistency, exception, reason, next event, matching mask should only be called from the main thread, and that's the clue. So as they explain here, blah, 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 OpenGL uses thread local state, so which thread you are on when you run matters, which doesn't work when the running program is in a different thread. So why are threads even relevant to GFCI? Well, they mention here no GFCI Sandbox, and that is because every single command we run is run in a separate thread. That doesn't appear to be the case because it's synchronous. It doesn't look like if I run a slow, let's see, import control.concurrent like thread delay, for example. It's expressed in 1/1,000,000th of a second. So if I say 1,000,000, then it waits for 1 second and ends. Whereas if it was being ran in a separate thread, like if I do it explicitly with for IO, then 1,000,000, then oh, not thread, but thread delay. Then it returns immediately with the ID of the thread, but it's the thread that runs the thing for 1 second. In fact, we can make that more apparent if I make the thread do something a bit more interesting, like put strlen done once the second is done, and now after 1 second you can see that done has appeared and has messed up my prompt, so I need to press enter to restore it. And yet, each of those commands are being ran in a separate thread. It's just that GFCI is waiting for the thread to be done before giving you back control and asking for the next thread. And like, I think this is so that you can more easily kill the threads if like you want to interrupt it with Control-C. I'm not sure why you couldn't just like wrap an exception handler around it, but whatever. I'm sure they have good reasons to do so. But if you write my thread ID, that gives you the current thread, but every time I call it, as you can see, the number is different. And that reveals that each line is ran in a separate thread. So if I now call this with, as they suggest, no GFCI Sandbox, well, I can't call it directly because that is a GFCI option, but I'm using stack GFCI, so I need to use, what's the exact syntax? I used it in quick run. It's dash dash GFCI options. So now this is the same as if I had ran GFCI dash F no GFCI Sandbox, but with the GFCI that stack has installed for me. And now if I call my thread ID, after importing it from control, of course, now every single call is done on the same thread. And that makes it possible to use functions like main, because now Gloss, who calls Glut, Glut has now access to its thread local storage, which is apparently only associated with the main thread. It's a bit common in the UI frameworks that you have to call the main loop of the UI framework from the main thread, and we can do that. All right. That is what quick cd quick there you go, quick run is doing. It starts GFCID. Let's go slower than I thought it would be. I did the whole thing so that it would be faster. I think it's still faster. It only takes a few seconds as opposed to like 30 seconds or something in stack run. Anyway, I think that I've found the bug. I will create a failing test in order to demonstrate it. Let's call that failing test. And as usual, I need to manually write fast afterwards, otherwise I would think that it has hanged. Okay, so the failing test is that if I have a bunch of giggles that are stop, and then I'm not sure if it's in the case that there is a stop after it or not, but they won't move. But it's either that if there is a stop after it, they will move but shouldn't, or that if there is not a stop, that they will not move but they should. So let's test both. So name is you, Giggles is you, Giggles is stop, Sheets is stop. Perfect. What do I expect in this case? I expect nothing to move. Indeed. So it must be the other case then. If there is no stop, I expect them to move. Do they? No. Aha, I was right, there is a bug. Because in that case, even though there is a stop immediately to the right, that stop is also you. So it will move, right? Okay, so what do I do? Okay, so this first case, has use and has stops, is the case in which I am splitting the chunk. But I think I should only split the chunk if that stop is not itself a use. Oh boy, okay. So, okay, so, well, this line has use and has stops says that the cell contains use and contains stops, but it's still ambiguous whether it's the same object that is both you and stop, or if they are two different objects. And the behavior should be different in that case. Okay. Okay. So, so it's not as stop, but rather if it's something that is stopping us from moving, and that is the case in which there is a thing that is blocking, I guess. Is blocking is an entity blocking, and that is if it is either you or if it is not stop, right? Because like if it is, I guess I should explain that. It would slightly, it is equivalent if I write it this way. If it is stop and it is not you, it's fairly clear that way. Because if it's you, then even though it is stop, it will be moving alongside the rest of the chunk, so it will not be blocking. Okay. So now we are interested in knowing not if something, if we have stop, but if we have blocking. So now I need has blocking. So for a particular position, so again, we need to worry about what happens if we are out of bounds. So yes, out of bounds are always blocking. So if we are not in bounds, then we are blocking, and otherwise we need to check if any of the sprites at the given position are blocking. It's not happy with this function. In bounds p in the level. There you go. Okay. And I think that is exactly what I was trying to express with this has stopped but not moving. So now, okay, so now I think the same logic as before works. It's just instead of asking if something is stop, I'm asking if something is blocking. Right. And I no longer need has stops. Cool. And now the test passes. And hopefully all of the other tests as well. Giggles is you test. Well, I should not call it failing test. I should call it you and stop move in unison. Okay. And if I test all, it should all pass. Whereas in the other case, in which you and stop, I guess, stop in unison if there is something that can stop in front of them. Shift was not even involved there. Then they should all stop in unison as well. Oh, I see it did broke something. GGGS. I can search for that. GSG. So this test, walk onto obstacle while stop, is saying that if I try to walk onto a thing that is stopped, then I shouldn't. But it is. So what's happening there? While stop. Because well, actually, yeah, no, yeah, this is wrong. Well, the test is correct, the behavior is wrong, because since Giggles here is both you and stop, the whole chunk should be stopped by this. So yeah, why is that happening? That is because here, when we encounter something which is blocking, I am allowing the rest of the chunk to go through. Ah, this is so much more complicated than I thought. Let's see. So, okay, so the reason I wrote that is for the case in which the elements of the chunk are not stop. Because in that case, if they encounter a blocking thing, then the thing that is next to it is blocked, but the thing, I don't know, look at the camera, yes. But the other things that are you, they can move on top. And, well, I now realize that there are not just two distinct cases, the case in which they are all stop and you, or they are all you but not stop, but like there could be like any combination in between. Well, I guess we should think about what we want to happen in that case. Let's write another test where I guess while some come on, while some are stuck. And in this case, well, I guess we can remove the fluff around it. There's a thing that is stopped. There is two different, let's just call them A and B. And one of, well, they're both U, but only one of them is stuck. Which one? Well, the view is probably different in each case. So if A, well, if A is stop, doesn't matter. It should move to the right. But if B is stop, then it's blocking. So A should not move on top. So we should have the same result here. Nothing should move. Okay. Whereas, yeah, whether if it was the opposite, BA, yeah, we can test all of that. We can both as a test. BAS, if it's BAS, then I do want it to, I want the B to move on top of the A, because the A is, even though it's not moving, it's not stopped, so it's not preventing B from moving. Oof! This is getting stupid hard. Well, at least the tests are not particularly hard, but the rules are. And I suspect that maybe the problem is that maybe I am looking at this from the wrong angle. Like I'm iterating from left to right and building a big chunk. Maybe I should build going from right to left and like checking, like accumulating the information about whether the thing is blocking or not. And so like I have a Boolean that tells me whether it's blocking or not, and then I encounter a thing that I want to move into a thing that is blocking, and so I know don't even bother, but also to update, and I now know that it is still blocking. So let's try that. So I have a direction here, which, so this gives me the rows. This gives me a list of rows, each of which is a list of positions in the direction of travel. I can't currently flip a direction. Maybe I should add that. So where is dir defined? Here. I'm gonna flip dir. Flip dir from dir to dir. If I have north, I get south. If I have east, I get west. If I have west, I get east. And if I have south, I get north. Alright. This line is getting a bit longer. Maybe something like that. And the direction is flip dir. Okay. Well, that shouldn't have changed the type at all, so what's wrong now? Oh, it's in my test. I haven't been paying enough attention. Could match, oh, because each of those should be an individual character rather than a string. All right, so okay, so now like all of the logic for chunking is completely wrong, and it doesn't actually matter that they are chunks, because I'm not like accumulating them into a big chunk. So yeah, I don't need chunks anymore. Instead, I'm returning well, I need a new name for the things that I'm returning. Movers? The things that are moving. Actives? Actives? I don't like the name. Movers? It looks like they are moving something, not that they are moving themselves. Movable? Moving. Movings. Actives. I have something to move an active. And for now, an active is just a cell position, but we know we want to update it to be a pair of a position and a predicate. So every time we have chunk, I want to return, I want to use active instead. Row actives. Row actives. And that logic is completely wrong now. I need to completely revisit it. But I think move active is still right. Guess chunk should now be active. Okay. Because for no, it's not right because the type is different. So instead of a list of position, it's just a position. So it's not even recursive. I just move this sprite. At the given position in the given direction. Okay. Pretty good. So what are these still complaining about? So for each of them it was returning, well, level chunks doesn't exist, level actives, and for each of them I'm calling move active. This is no longer a list, I no longer need to reverse it. Or do I? I said earlier that I was only updating the array once every time the user presses a key, but I now see that I'm updating it once per chunk. So now that I'm doing it every sprite, it's pretty much the same as the thing that I did not want to do. Okay. Well, nevertheless, I am moving the active, and it can fail. I'm now thinking about maybe changing that so that it cannot fail, because I'm making sure ahead of time now that nothing is ever moving out of the full boundaries. Anyway, one thing at a time. So yes, row actives is now completely wrong. I'm dividing it into chunks so that if I have like 4 different characters that are all U next to each other, they can all move to the right at the same time. And that's no longer what I want to do. I was doing that because I was traversing from left to right. And I wanted to accumulate all of the characters that were U in order to decide whether that whole chunk could move to the right or not, if they were all blocked by an obstacle on the right, and I now want to do the opposite. I want to go from right to left, and so I already know whether there has been an obstacle, and then whether each of them can move to the right. And the reason I'm doing it this way is because some of those can themselves be obstacles. Like if something is both you and stop, then if it cannot move, then it is an obstacle. But if it can move, then it is not an obstacle because it will no longer there. So that's why I have to go from right to left in order to know whether it's going to move or not. Okay, so before we were returning something, this was called level chunks. So the comment is no longer correct. All of the actives, like I really struggled to find the word for that. All of the active cells, that is, those which are moving in the direction. No, okay, okay, right. I mentioned this throughout the level because there's a different function that returns them only for a single row. Okay. All the active cells, yeah, throughout the level. And here, an active cell. Okay, so maybe active is not that bad of a name. That is cell whose entities move in the direction that they are pressed. And it's not all the entities, it's containing some entities, those which are you, which move in the direction that you're pressed. Okay, now that we know what it is that we're returning, it will be easier to write the function that actually returns them. Okay, so level actives, active cells. I don't want to rename it to active cells because I know that in a moment, in order to implement push, I want to change what I'm storing. Instead of just being the cell position, I want to store the individual sprites inside it. So maybe I can at that point rename it from active cell to active entities, or just keep the word active. All the active, I really hate that name. Okay, active cell, I'll rename it later. The levels, active cells. And where else? Oh yeah, that logic is all wrong because I'm still expecting a row. Alright, and in lowercase, active cell. Level actives. Level active cells. Okay. Okay, so I want to move, to call move active cell on all of the active cells that have been computed for the level. Okay. And how do I compute them for the whole level? I compute them row by row by calling row active cells and then concatenating everything using fold map. And for each of those, I traverse in the opposite direction, flip the ear, that the user pressed. So if the user pressed the right key, then I want to traverse all of the positions from right to left, not from left to right. Okay. I'll use those helper functions to know if a particular entity is blocking, if a particular cell contains blocking entities, or is out of bounds, in which case that should be blocking as well. And by blocking, I mean it blocks the movement. And if a cell has any sprite that is you, that is, if it it needs that in order to have the potential to be active. It's active is if it has you and there's no blocking cell in the direction of the movement. And we already know that because we're coming from that direction. That's why for each row, we are starting from outside of the boundaries of the level, already knowing whether the cell in that direction is blocking or not. So that's why we're beginning with true. The tool indicates whether movement is blocked in the direction here. Okay. So, I'm going through the list of positions. If there are no more positions remaining, then there are certainly no more active cells on this row. If I know there is an obstacle that is blocked, then regardless of what is in this next position, it's not going to be included in the list of actives. So there's no something, colon, something else. It's directly, I am recurring, go on the tail, and I need, like the tail PS, and I need to check if there is an obstacle there. So it has stops, we just looked at it, it just checks if it's inbounds or has stop. Okay, perfect. And what is that? That can't even parse because the different definitions for go have a different number of arguments. So that must be where we stopped abruptly last time. So if it's false, then what are the possibilities? So well, if P has a U, then it means that this P is active because it can move in the direction of travel. So I include P, that's it, that was easy. And I recur with, I guess, same question? Well, it depends. What does it depend on? So here, it asks if anything is stop. But his blocking is a different question. Right. So something which is blocking, unlike what I said earlier, where it means it's something that is blocking the movement of travel, something that is blocking here is something that is stop but not you. So is blocking is more appropriate when the thing it's okay. Okay. Since P is moving, then I don't want to count the thing that is moving as blocking. So that's why here I want to ask if there's any blocking in P and then recur on PS. Whereas if otherwise, if there is no entity that is you, then has blocking will still return the same thing because there's no such entity. So why are we even looking at has stops here? Oh, right. So yes, if there is a blocking entity in the direction of travel, then the U's in the current cell count as obstacle because they're not moving. So that's why I am only checking the simpler condition if there's anything that is stop here. Whereas if there is this U that I need to check the more complicated condition has blocking. I should probably find a better name for as blocking. A non-U stop. Yeah, I like that better actually. As non-U stops is a non-U stop. It's barely longer and it's much clearer. All right. So otherwise, if there are no U's, then I don't want to include the cell, so I directly recur on the tail, and I again need to check, and it doesn't matter this time, whether I use has stops or has non-use stops, because I already know that all of the cells there are non-use, so both functions will return the same thing. And I think that covers all of the cases. Let's see, why did we have such complicated stuff before? Presumably in order to deal with the chunking, but we don't need that anymore. So, let's try that. And meanwhile, I got a compilation error. How's that happening? Let's build it in the bigger window. Or maybe use GFCI stack REPL Giggles is lib. Okay, so error, the variable not in scope has non-use stop. It's because it has non-use stops, plural. And that was it. So we should now be able to run, although there's a warning somewhere. It's in draw. I guess I'll look at it later. It's not, I don't think it's a consequence of what I just did. So, I can move around, and if I want to test whether things are working now, I need to know what. Well, actually, this is a re-implementation, so things should still be working. If I'm walking into the side, it still works. If I'm walking into the text, which is stop, it is blocking me, and there are some more complicated cases. If I walk on top of the other things that are use, and that should happen both when I'm walking onto the edge of the screen and when I'm walking into something that is stuck. That is clearly not working, because I was able to walk on top of the text, but I can't walk down. I can't walk up onto the text. Can I walk right? I can only walk left. Oh, now I can't walk left at all. Okay, what is going on? Clearly, this is not working. So let's maybe write some simpler tests. In Giggles is test. Right, so we already have some tests which should now be failing. So if I do test all, then, well, then one of them will be failing, but which one? Well, presumably the error message will guide me to know which one, because again, I didn't write my I wrote my own test framework, so it's not as fully featured as HSpec or Tasty, so it's not even like displaying the name of the test that has failed. And in fact, it's not running it either, but that's because of the warning. GCID prefers to display warnings instead of running the thing I tell it to run with --test, unless I use --W, which means that the warnings are not that important. Warnings are important. I will look at it, just not right now. Okay, so it says, well, that's the warning from before, and now, oh, I know why there's a warning, and it wasn't one before. It's not because I forgot something last time. It's because in the hope of making you wait for less long, I switched to a more recent version of the stackage LTS, one which corresponds to a GHC I had already installed for a different project. So we bumped from 8.8 to 8.10, I think. And as a result, I guess 8.10 has more warnings or something like But at least I didn't have to download a new version of GFC. Okay, but we'll fix that in a moment. So we expected X, S, Y, Z, which tests expect that. This one, walk onto obstacle mid-level. That sounds a lot like the bug I've just encountered while experimenting in the game. So things start like this. W, X, Y, and Z are all U. S is stop. And I move towards the right. I expect W to move on top of X, X to be blocked by the stop, the Y that was on top of the stop to move out onto the Y, and for Z to move to the right. Right, Z moves to the right, Y moves boop here after the stop. But what I got instead is the W did move on top of the X, that's great, and the Y not just moved out of the stuff, but it moved on top of the Z. What is that? Oh, I know why. So I remember being careful earlier when I was moving the chunks to be moving them in a particular order, presumably from left to right or from right to left. Yeah, from right to left, so that okay, because like even though I'm trying to do things as purely functional as I can, that part feels very imperative to me still, because we have a big array and we're like mutating one cell at a time, and so we have the same kind of issues we get in that case, where if I move the contents of this cell to the right, and then the contents of this cell to the right, and then the contents of this cell to the right, I don't get the same result as if I move the contents of this cell to the right, and then the contents of this cell to the right, because now everything is on top of each other, right? And that's exactly what we get. So that's the bug. So that means that when here I called move active cell, I'm calling those in the wrong order. So I can call reverse in order to fix that. Yeah, I guess. So does that help? Now it's a different test which is failing. So we expect GGG. But we got GGGS. What? There's an S that just appeared. Oh wait, no. It's this test. So it's just the thing that I expect is wrong. If I started with an S there, I should still have an S, but the G should be on top. Why do I expect that? U and stop and unison, because Giggles and sheet. No, only Giggles is U, but they're both stop. So yeah, I would expect them not to move. So the problem is not that I forgot to include the S underneath, is that I forgot to include the S at the end. Okay. Excellent. Tests have passed. And now let's look at that warning. So Giggles U, draw 59. No variables bound in the record wildcard match are used. Indeed. Great. Okay, so let's have that warning fix with the bump in the resolver. and then the rest. Yeah, this comment is still wrong. All the active cells within the row. Maybe within is simpler than throughout. Within the level. Okay. Move active cells, left chunks. Okay. So the reason I did that is as a step towards implementing push. So the first thing I want to do is to change, instead of keeping track of the cell that we are moving, because in move active cell, here I'm moving all of the entities that are u in that cell, and it will no longer be true when I implement push, because I will be moving both the things that have been pushed and the things that are u. But I can't just do that by saying move all of the things that are push and the things that are u, because there could be things that are push in the cell that have not been pushed. Like if there's a thing that is push and a thing that is u that are stacked on top of each other, if I am moving out of the thing that is push in the same way that I'm moving out of a thing that is stop, then only u is moving, not the thing that is push, because it's not being pushed. It's only being pushed if there is something that is u that is pushing in its direction. So that's why I need to be more precise. So now instead of active cell, let's say active entity. Active entity. Oh, plural is not that. So only the singular occurrences. Okay, and now I guess the plural occurrences. Move little active entities. Oh, not this one. Oh, I should search for active cells. This way I will only get the plurals. And finally, all of the lowercase. Active entity. And apparently there was all the lowercase. Okay, cool. Right, well I need to change the definition, because currently I changed the name but not the meaning. So instead of a cell position, it's now going to be a cell position and I guess an entity. So there's a bunch of entities in there. And yeah, I think last time I said I wanted to pick out the entities using a Boolean predicate. So entity to bool, and whenever I see a tuple, I think, would it be better as a record? Because then we can give names to those components. So active cell is the cell, and active, I guess, subset is those that satisfy the predicate. Okay, so now we have to fix all of the type errors. So 91. Yeah, I'm not returning just a position anymore. I'm returning an active entity consisting of a position and, so in this case, I have discovered that there are things that are u, and those are the things that are moving. I'll need to make this more complicated once there are things that are push, but there are not yet any things that are pushed. I'm only getting ready to implement is push. So so I guess is u. Those that are u are the entities that are moving. Apparently this doesn't work. couldn't match entity bool with bool. Is you takes a set of rules, but still it's not the error message I would have expected, but apparently it fixed it. And on 100, okay, so now we have an active entity and active cell. Yeah, maybe cell is not the... is it a good name? Should it be active position? I guess active cell is fine. Well, it's a cell pause. Active cell pause. Active cell should now be active cell pause. Okay. And the predicate is active subset. So I guess is active would be a better name. And it's not happy with this. Oh, because I just need to enable record wildcards, which I simply haven't yet used in this file. It's fine. All right, tests are passing. So I guess I can call that active entities instead of active cell. Okay, there's another simplification I want to make before I forget about it, which is that now that I'm starting from the edge of the screen and I know already that since I start at the edge of the screen that this is blocking, then it means that I don't need to do the complexification that I did previously, where instead of iterating over all of the cells within the level, I iterate over all of the cells starting from outside of the level in. And so I had changed that where in level, I think, where we, maybe not, direction maybe? Well, it's the function I just called from rules, so let's just look it up. Directed level indices, this one. So it was previously doing the same thing of not including the position that are immediately outside the bounds. So I don't want to return all of that, nor all of those, nor this one, nor this one. And I can do that simply by not overextending. There you go. Easy. So I'm back to a saner semantics. Oh, I have a whole bunch of those comments to change. Because I gave an example for all the directions. Alright, and the test still passed, right? Have I introduced a loop? Well, let's see. So, in Giggles is u.test, I define a whole bunch more things than I thought. Oh, right, it's the whole interface for defining tests in addition to the tests themselves. So let's just run them one at a time. So is this one passing? This one's looping. Is this one? They're all looping. What? Why are they all looping? Okay, this is bad. Don't know why they are looping. What is the change I just made? Did I make something dumb? Yes, I did do something dumb, which is that here I was previously going from high plus 1 down to high, down to, well, just before that would be low, and then low minus 1. And I want to start from high instead of high plus 1, so I deleted the plus 1, but now I still have the high here as the second element, and so now I'm saying that I want to go from high down to low by increments of 0. So that will of course take forever. So that was the dumb thing I did. Let's fix that. Here. All right. So only iterate over the cells. Don't iterate over cells outside the verbal bounds. Okay. So that is much safer. When I introduced this, I was slightly worried because, well, there is no value outside of the array, and so I could index out of bounds and crash the game. I had to do a couple of tweaks in order to make sure that this doesn't happen. Oh, I can remove those as well. That's also simpler. So I don't have to check, not this one, this one's fine. It's the inbounds calls that I no longer need. So I was checking that, oh, if the position is outside of the bounds, it's to think about it in the case of stuff. If the position is outside of the bounds, then I consider it to be stuff, even without looking at the non-existing contents and finding an entity that it's stuff. The boundary is always stuffing the thing. So I can just delete everything that mentions is bounds because it's no longer relevant. We're always going to be in bounds. And that is, I guess, part of the change I just made in the previous commit. So I can amend. And then the rest is add name is push rule, but it doesn't do anything yet. Okay, and we'll make it do something next time. See you then!